Hello, everyone. My name is Jeremy Morton. I'm the CEO and founder of Expert TA. I would thank everyone for taking the time to join today. We appreciate your interest in the new pre-class videos that we have to offer. I want to talk a little bit about the format of the presentation today. Anyone who is going to be potentially adopting the videos will likely want a homework component to go along with that. And so it makes sense to talk a little bit about the Expert TA homework system. But even if you adopt only the pre-class videos, you'll see by the end of the presentation today that they are available in an assignable form so that you can hold students accountable to watch these videos before they show up to a class, or accountable to watch the videos at whatever point. And based on that assignability, it will still make sense for you to see the elements of the Expert TA system associated with our question types, how assignments are created, and the other surrounding factors. What I've got pulled up here now is the Expert TA main website. There's a lot of good general information there, and I would suggest that if you're wanting to learn more about other things that we have to offer, this would be a great place to start. And under our products, there is a dedicated landing page here that talks about the physics video library and other elements of the videos, that many of which you'll be seeing today. There are some example videos that you can watch there, and a table of contents showing our coverage for Physics 1, which was released for this fall semester. We have several universities that are currently using this and more adopting in the spring. And then Physics 2, which says here is going to be available in spring 19. There will be some videos available, but the full sequence will be available in fall 19. Okay, so at this point, what I would like to do is lay out a little more about the agenda. We're going to spend about 30 minutes looking at the Expert TA system in general, how to create assignments, control grade preferences, and you will see some about the videos and how to access those during that time. Then we'll spend about 10 minutes looking at specifically the videos, how they can be distributed to students in both assignable and non-assignable forms. And then we're lucky to have Dr. Amaya Kolakar, and we may have Dr. Chris Dustin, who are the two authors of this video series, on to talk about the videos themselves and the progression, how these videos have come to be in the current form that they are. At this point, I'm going to go over to this tab where I am logged in as an Expert TA instructor. We don't want to spend a lot of time talking about the system today, just the really important factors that differentiate us in that limited 30 minutes that we have. If you see things that are interested related to this and you would like to ask more questions, we'd be happy to answer those offline in an email, or we could do an extended personal session where we give you a more in-depth tour of the Expert TA system. Here is the basic class management area where you're taken when you as an instructor or students log into the system. You have a drop-down that allows you to move between different classes or different sections of a class. For any given class, there is an area at the top that has potentially links to additional class resources. You can see set simulations, and here we will be in a few minutes clicking on the Expert TA pre-class video series for those who are adopting that resource. And then down below, there is an area outlining all of the assignments in this particular class. You can see there's basic information, the assignment name, the dates that are associated with each. If you have different weights for different assignments, you see those here. And then the instructor template that is used. You have the ability through grade preferences to allow a lot of customization to how students interact with the Expert TA assignments as they take them, and that level of customization is important. We want to go through and show that right now. Up here in the top menu, under Instructor, there are two links here, one for grade preferences and one for a whole set of controls you have for an academic integrity tool suite that we have. First, let's look at grade preferences. We won't spend a lot of time here, but it will give you the idea that you can configure assignments and a pretty high degree to control things like the number of submission attempts a student has on each question, how many points they'll lose for incorrect answers that they submit. You can control whether they have access to hints and feedback during an assignment. Those are very different hints and feedback in Expert TA. We're going to be showing that in the context of taking an assignment. You can control deductions associated with accessing those pieces of information, and it, of course, can be free to students. So this could be set to be 0. You have the ability to control late work, randomization of variables and phrases, whether or not partial credit is provided. If a student, for example, uses up all 5 tries and has not arrived at the correct answer, would you like to give them some credit if their answer is close? If partial credit is set to be yes, they'll receive some credit for that. If it's no, then they have to arrive at the right answer by the time they've used all of their attempts. Again, this is just to give you a high-level idea that you have a lot of room for customization of assignments, and you can create different templates in the event that you want to have different settings for different assignments. We can just show you here you have the ability to add a template, and then as I click through here, you'll notice that the structure to the right really doesn't change, but the parameters inside of these fields do. When you create a grade template, it's going to be available for you when you create an assignment, which makes it very convenient. You only have to set up all of these settings once, and then it's available for every assignment that you create. At this point, I'd like to go in and create an assignment together. Back from the main class management area, I would choose from the class menu here at the top, Create Class Assignment. Again, we have a full suite of tools to manage your class. You have to be able to manage your roster and see your grade sheets and other things like that. You would expect that in any homework system. Today, we just want to focus on the things that differentiate. Let's go in and say Create Class Assignment. I had several assignments. I'm going to make this homework 5. You can see from one screen, you have the ability to control everything to configure this assignment. The weight, we talked about the grade preference templates. Any template that I've created from this area will be available in the drop-down. I'm just going to make this a homework assignment. The publish date is the first date that the assignment will even be visible to students in their lists. Most of the time, instructors make this the start of the semester so students can see what's coming. But if you have a pop quiz, you may want to hide that from them. Any work done between the start and the due date, students earn full credit. Any work done between the due and the end dates, students will earn whatever late work percentage that you have set for them. All of these dates are able to be changed with a drop-down calendar control. We can look at the interface below that allows you to choose from problems in the Expert TA system. I'm going to show problems that involve our Freebody diagram question type, as this was stated from many of you attending in email correspondence to us as something that would be of interest in seeing today. I'll switch over to Newton's laws here, and you can see that there are actually 2 sections in this chapter that are dedicated to just free body diagrams. I'd like to add a problem here, 596. The 2 sections are for problems that are in equilibrium and ones that have net acceleration. So here we have a man pushing a crate up a slope, and net acceleration is going to be involved. So this is one problem that we'll want to show today. These will not involve any equations or any algorithms. It's just for practice with free body diagrams. There are 30 or 40 of these available. If I click Expand All, you can see the view that you're presented with was designed to resemble opening a textbook to the end of the chapter. And let me also just click Show Answer here. We've been told by instructors who use Expert TA that this is very convenient. You can see the problem statement, the image if there is one, and then all of the steps of the problem to be solved. You can see here that there are some problems where free body diagrams are part of a multi-step problem. That's the case here for this problem 535. And I would like to add one of these as well so that we can show you some of the other question types that we have available. And then the only thing that I would like to add to this assignment is one of the Learning Expert TA problems to introduce students to our environment and to specific question types. We have these video-based problems that walk them through these aspects of the system that they watch and then answer questions. And at that point, you know that students are proficient with the technology and they can really focus in on the physics. Here you can see that if I've navigated away from where I selected the problem, I can mouse over to be remembered about the problem details. I can drag and drop to reorder problems in this assignment, which I'll do. I'll make the Learning Expert TA problem the first. I can control the weights of the problems here, and I can control the weight of the assignment. You, of course, have the ability to set things like extensions for students if they are sick or just need extra time. Life does happen. So we have that full suite that, again, I've mentioned a few times. If you're interested in what you see today and want to learn more about all of the aspects of Expert TA, please let us know. At this point, in the essence of time, I'm going to save this assignment. And you can see that this is now waiting for the students. I'm going to simply take this as an instructor because the interface is going to be the same interface that your students will see. So this will allow us to demonstrate what these look like. The only other thing that I could do, I guess, before we move on is I want to show you that for the videos, you would have a drop down here under books. The selection that I just did was from the main collection of questions for homework that we had. But for the videos, they're all stored in a separate collection. And if I could just expand one of the chapters with these videos, which is videos on 2D motion, you can see in this video we specialize the kinematic equations in a particular order. It gives a nice description of what's in that video, and instructors can even preview the video to know whether they want to use it or not, including going full screen so that you can be able to really see all the details of the video in the larger format as you're trying to determine whether you're going to put these in. And then those can be added into an assignment. This is the assignable nature of the pre-class videos. And of course, there are questions that have been authored that students will be able to answer if they've watched the video, but probably won't be able to answer if they haven't. So this is what you'll see in a few minutes holds the students accountable to that. Let's go back out now and take this assignment to show you some of our basic online homework. Here's this first problem that is similar to the way that the pre-class videos are delivered. There's the video in the problem statement area that the student can watch. This is 1 minute and 51 seconds. We're not going to watch this full video, but I could just give you the idea that it introduces students to the Freebody diagram question type. It shows them all of the controls and talks about the environment. And by the end of the video, it shows them everything, including the correct answer. And then we just ask the students to go to around 1 minute and 35 seconds so they can see what the correct Freebody diagram was. Their only task is to recreate that. And again, now you know they're comfortable with the controls and that for future questions that they are focused in on the physics and not how they make things happen inside of the system. I'd like to go through and show a Freebody diagram question now. The interface has been designed not to include Flash. This works on any browser and any device. You can do this on an iPhone or an iPad even. To put a force in the diagram, you say add force, and I will change that force to be 0 degrees. And you can see that everything here is snapping to the rotated coordinate system associated with this problem. We'll put the force F in the right place. We can use the drop down here to make the normal force at 90 degrees. We can add in the frictional force. Now this is accelerating up the slope, which means that it's moving, but I'm going to incorrectly use the static friction force and put that at 180 so that you can see an example of feedback. I need one more force that's going to be the gravitational force, which is acting down. And as you can see, I can use the drop downs here to control the angles if they happen to line up on the major coordinate axes, but that's not always the case. And so what we've done here is we allow students to drag these forces to change the length and the direction in order to let them produce something that is as close to what they would draw on paper as is possible, which I believe what you're looking at is fairly close to that. Initially, when we designed this, we wanted to grade these for proportionality with a tolerance, and we realized that it was going to be very challenging for students to eyeball these diagrams and work within a tolerance, and it was probably going to serve to frustrate students. And so you'll see in a moment that we provide a real-time calculation of their F total X and F total Y. In this case, F total X was a little bit on the negative, and so they can use that to know whether it's roughly balanced rather than eyeballing these things. I'd like to submit this, noting that there are two errors. This should be F sub K, and this is accelerating, so F total X should not be 0. First, the feedback lets us know that specific feedback is available, that the answer was not right, and says the object is moving. Please think about what frictional forces should be considered. If I change this to be F sub K, let's also show, before I move on, one other example of feedback that we can provide that's helpful. Students love to incorrectly do things like put acceleration as a force in a free body diagram, and they really shouldn't do that. We consulted with PER experts and active instructors about this, whether we should even include acceleration in the drop-down, and the general consensus was they can make that mistake on paper. Why not let them make that mistake when they're drawing in your environment? Here, if we click the submit button, you'll see the feedback says there is no acceleration force. Acceleration doesn't belong in the free body diagram in this way. If I now delete that force and take this back to where the F total X is 0, you can see that we can even grade based on proportionality. And so here it lets the student know there, again, is feedback, and the feedback says your diagram is not proportional. Is the object accelerating, and if so, in what direction? Your diagram should communicate that. And now we can fix that by simply moving F up the slope to make it larger. We can see F total X is now net positive, indicated to the student, and this should be accepted as a correct answer. Let's move on now so that you can see other question types in Expert TA. Part A of this problem is asking for students to draw a free body diagram for this particular object hanging from 2 cables. We're going to skip over this part since you've just seen that question type in action. And we want to move down to another really important question type that was really at the foundation of Expert TA, the ability for students to input algebraic, symbolic answers, and for those to be graded as more than just right or wrong. I think most instructors embrace the idea that students should be working with variables. And when you give an exam, unless you're doing Scantrons because you have 300 students, you're typically saying to students, show all of your work. It's not that you're saying to students on the test, all I care about is your final number. You say, I want to see the steps. There are an abundance of questions in Expert TA that are designed to reinforce the problem-solving process and to have students working with the symbolic answers. So just a little bit about this interface. There's an entire chapter in my PhD dissertation on this where I analyzed what other systems did. I tried to identify points of frustration where students could have trouble. And one of the big things that I found out is that if you make this an open-ended text area where students can type in anything that they want, that leads to variable confusion, which causes a lot of frustration. If the correct answer is X plus 3, and students type in capital X plus 3, and the system gives them a red X and a 0 and no feedback, they clearly understood the concept, and it's just a syntax issue, and that's not where you want to be. So how do you type in alpha when there's not one on the keyboard? When you go to do a T subscript 1, is it HTML style subscript tags or T_1 like LaTeX? We don't want that to be an issue. So what we've done is we've made this a restricted nomenclature where the students are provided with the variables they need, plus some variables that they have to look past so that you're not reading them too much. They are able to click these buttons to add those in, but they can also type using the keyboard. You can see here as I type T, it's restricted to only those variables that are valid. And so even if I, with a lowercase t here, type in 1, it knows that I meant capital T1. And so this avoids a lot of student frustration and near misses for the system just not recognizing an answer. We put a lot of effort into that. Let's type in a couple of answers that are not correct so you can see examples of feedback. Here, we would have, for the sum of the forces in the X, T2, and we do need cosine beta. I'm going to put minus T1 for the component of the tension in cable 1, but you can see the angle here is measured from vertical, and students quite commonly think that horizontal is cosine and vertical is sine, and so many of them put in something like T1 cosine alpha. If I click submit here, it's going to say the answer is not right. It lets us know that specific feedback is available. And the feedback says check your trigonometry and refer to the Freebody diagram. Angles beta and alpha are measured from different reference points. This feedback is not some static response. It is specific to that mistake that was just made. If students put in something like T2 minus T1, which they commonly forget to include trig altogether, the feedback will be different. In this case, it says you've forgotten to include the trigonometric terms associated with X component for the tension. If the students type in something that is very far off, we are going to let them know your answer is not right. We don't have any specific feedback. We disabled the feedback button, so there's no chance they could lose points by clicking that. And we suggest that they might access hints and review the relevant material. So the difference between hints and feedback is specific to the mistake a particular student's making. Hints are hard-coded things that are meant to help any student who's having trouble framing the question get started on that question. At this point, I've got 2 tries remaining. I do want to put in the correct answer, but I want to show you how robust our math engine is. And so I will put in the right answer, which is T2 cosine beta, but let's use a trig identity. I'm going to type in cosine, so it's 1 minus sine beta squared would be cosine squared beta. And I'll divide now by that cosine beta. It should be minus T1. I'm going to put plus T1, multiply by a -1 here. And then as we said earlier, it should be sine alpha in that case. That answer is going to be accepted as correct, even though it's in a different mathematical form. We have the ability to recognize any mathematical equivalent. And we can actually do this not just for the final correct answer, but any mathematical form of these near misses. Now that you've seen a little bit of feedback, I want to talk for just a few minutes about how good our feedback is in Expert TA for all of our questions. It's related to a 6-year data mining initiative. We have a library of physics questions that covers Physics 1, classical mechanics, all the way through superposition, thermodynamics, and then we have Physics 2 coverage, E&M, optics, circuits, including all of the chapters at the end that are needed for folks who do modern physics at the end of Physics 2. That library is used at hundreds of universities with tens and tens of thousands of students every semester. They're working problems just like what you see here. They're not always putting in the right answer on the first try. And the thought occurred to us, why not data mine every incorrect answer submitted to every question, which we've done. We run it through a mathematical process to identify mathematically equivalent ones. And what you wind up with is for every question, what was the #1 most common submitted incorrect answer for that? What was the second most common? And so on. And then we take that and we put it in front of experts who teach college level physics or high school physics. And I just want to show you what the result of this looks like. I'm going in now as an administrator in the Expert TA system. And I'm just going to an arbitrary section here, projectile motion. We were doing forces, but we'll go into projectile motion. And I'll grab a problem from in here, 4318. I want you to see what this looks like. So we've got a basketball player who's shooting free throws. There's a 5-part problem here. Part A, it looks like, is asking for an expression of the basketball's initial velocity vector. There are some hard-coded hints that the student can access. There is the correct answer that's coded in here as well. But now, in addition to the correct answer, we have all of these anticipated answers that are not correct, and we have feedback that has been written by a college level or high school level physics instructor. Your answer suggests the components are larger than the magnitude of the vector. This is non-physical. So we used to be able to provide feedback to students early days of Expert TA only based on math errors, like a sign error on a term or a trig error, because that's programmatically easy to do, but it doesn't really hit on the conceptual aspects of their mistakes. Doing this data mining and allowing an instructor to look at that wrong answer and say, what would I tell a student who came into my office in office hours about this mistake? So after this is done, any student working this problem in the future in any instructor's class, the instructor does not have to do any work related to this. This is in here for you and your students. When the student puts in an answer, we check to see, is it correct regardless of the mathematical form? If it is, they get a check mark. That's great. If it's not, we start looking through this anticipated list of the most common mistakes. And if we find a match here, we can provide the students with this feedback. And if it's their last try, we can give this partial credit that has been suggested for that answer. Now, if we make it through this list and we have not found a matchup for the student, there's still plenty of opportunity for feedback because of the other programmatic aspects, like is it off by a factor of 10 or 100 or 1,000, or students quite commonly forget to divide through or multiply through by a factor of 2. We check for those things, and so students still have the opportunity for feedback. If it's human written, we want to prioritize and put up front because that's where there's the most room for the conceptual aspect of the feedback. This is an example of an expression in Expert TA. It's an important question type that we have. We wanted you to see it and to see the feedback that's provided. We, of course, ask students in many of our problems for numeric calculations. You can see one here. We're asking them to solve for T1 in newtons. I will point out that we have the same level of feedback and have done the same level of data mining here so that it's not just whether they got the value right or not. We can tell them a lot about the nature of their incorrect answer based on our data mining effort there. This is the basic Expert TA system. I can show a few additional features at the end if time allows, but this is the 30 minutes that I wanted to take doing this part, and now I'd really like to move over to the videos. For the videos, we can still stay in this environment, and there's just an assignment that I want to visit, and there's also a dedicated landing page for Physics 1 that we can show you. And I should point out at this point that our homework system is one product line. It's $32.50 per semester. We cap that out after 2 semesters, so if students have to retake Physics 1 or Physics 2 or both, they still are charged a maximum of $65. The videos are $32.50 if you want to use the videos by themselves, and if you use both the homework and the videos, we give a discounted price of $60 for that package. And when paired with a free book like the OpenStax College or University Physics, the total cost to the students is $60 for a complete educational platform. But I did want to make sure before we get into this that the video series is not something that if you're using the homework that just comes along with it. It is at a different price point. So if you have adopted the videos, one of the things that will happen is in this additional class resources area to the top, you will have this link, and your students will be able to click this and be taken to a clickable table of contents laid out presentation where you have each of the topics that are like chapters, the subsections here. There's all of the videos. This allows students to watch those at their own pace, and they can rewatch those and revisit those at any time. You can see our coverage. This is 65 videos that we have right now for Physics 1. Ultimately, this will probably be closer to 100 total videos. And I mentioned before that they are truly lecture replacements. These are not high-level conceptual videos. What you want for anything, let's just pick projectile motion. You want to, as an instructor, go through and either fully derive the kinematic equations or show those kinematic equations and talk about them in detail. Let's say that you do the full process and you derive them for your students so they can see where they really came from. Then you want to talk about the application of the kinematic equations for a while. You would say, here's what these terms are and how they come up in problems. Then you would certainly want to show example problems where you're plugging the values and doing all of that. And then sometimes you want to have post-topic summary videos. This is the level of detail you should expect in the series that we're producing. And again, there's 65 that were released this fall, and we're adding to those. One of the things that we're really interested in doing is adding lots and lots of work example questions. At this point, I'm just going to switch back over to this interface so that we can talk about how they are assignable. You saw earlier when we created homework 5 together that there's a book drop-down that allows you to get to the pre-class video collection. I have already created a pre-class assignment for today, simulating if I had a lecture that was at 2 o'clock today, I would want students to watch the videos before showing up to that in the flipped classroom format. The students would see the basic kinematic equation derivation. I want to know that they're coming in prepared, so I don't want to just tell them the videos are up on YouTube. We want them to be assignable. I'll click Take Assignment, and I'll go back up to problem 1. So this is 711 Work Introduction. This is 712 Work Example. And as I click through here, you can see that in addition to the video being available, there are questions down below, as I mentioned earlier, that are designed entirely to determine whether the student watched the video. This is the incentive for the student to pay attention to the details as they're going through it. And now there's accountability. You're more likely to have prepared students if you do it in this way. I also want to talk about the video and their history. We did not decide that we wanted to produce pre-class physics instructional videos, and then we started putting these together. These videos have been around for 4 years and being refined and updated by the 2 authors, Dr. Chris Dustin and Dr. Amaya Kolakar, who are here. They're going to talk in just a few minutes after I'm finished with this next segment more about this, but they essentially, for the last 4 years, have been doing the flipped classroom at their respective institutions. And with Dr. Kolakar at Auburn, the entire faculty there is on the flipped classroom, and they use his videos. His videos and Chris's are more lower production value. They're drawing on tablets, they're writing things by hand, and that's what's feasible for an instructor to do. We came to them to take those videos and enter into an agreement where they have the physics that's been thought about and refined, and we are just making these into vector animations and typeset math, closed captions, and doing that component of it so that they can be used universally. And here, let's now go over and take a look at an example of a finished video. Let's watch maybe 2 minutes of this just so that you can get a sense of it.
And this will make it clear why we use certain ways of doing dot products. Alright, here comes our favorite ramp that makes an angle theta horizontally. So let's consider a block, and we apply a force F on this block on this horizontal surface for now. All right, and there's friction everywhere with a given coefficient of friction mu k. So this thing is moving to the right. There is displacement to the right. Let's say this thing is 2 meters. Let's say the ramp is 3 meters. All right. So the displacement on the ramp is downwards, and as soon as the block goes over the edge, there is no force acting on it. So the force acts only until this point here. Okay, and then it simply slides down the ramp. So now we want to find out the work done by each and every force acting on this object in this situation. So what do you do first? You always draw a free body diagram. So a free body diagram, there will be two different free body diagrams, one on this horizontal surface and the one on the ramp. So on the horizontal surface, what does a free body diagram for this object look like? We have mg down, we have Fn, the normal force, going up, straight up.
I think that's probably enough of a sample for listening to the video, but I may skip through just to show you. This is a worked example. So as I skip through, you can see that a free body diagram is going to be drawn. There are going to be equations that are going to be put in place. Additional work will be done. We have to look at the section where the block is on the slope. The same thing will be done. A free body diagram. Equations will be applied. This should give you an idea of the production quality. And again, I described earlier the derivation, the theory, the topic, the application, and example components in all of these videos that we have. So at this point, I would like to open this up to Chris and to Amaya. Let's first go to Dr. Amaya Kolakar so that he can talk to us a little bit about what he's done over the past 4 years related to the refinement of these. He does PER research. He's attending AAPT meetings and publishing material on this. Amaya, talk to us about how you collect data and the process you've gone through to make these videos better and better.
So hello everyone, I hope you can hear me. So let me start with my story of starting to teach in Boston University. And that's where I came across this flipped classroom format and all. And so I decided to use flipped classroom when I came to Auburn. And to do that, I started making my own videos. I was using some other videos from other systems and other people at Boston. So here I started making my own videos about 4 years ago. And then I gave it to my students and got feedback from the students. And I'd also embedded quizzes and questions into the videos. So this gave me an idea of how long the students are watching videos, how much they are getting out of it. I also asked them questions about how useful did you find this video, or are there any confusion points, or how confident you feel about the material and stuff like that. And so I got a lot of those data from the students, along with the right and wrong answers to the quiz questions and the viewing history of the students. And that told me a lot of things about the video and the content in the video itself. And then again, talking to students in class, I got some more feedback and I refined those videos over time, such that I have basically the same kind of comments from students these days, and they like the videos. Even if they don't like the flipped classroom or the active learning styles, they still like the videos, so they can visit the videos back and forth all the time over the semester. And if they have a sticking point, they again always go back to the video or talk to me about it. So it's always been good. So I have data from about 4 years to corroborate the usefulness of the videos. And then I also go back and look at their exam performance and relate that with the performance on the videos. So it's good to know that over the semester, their video pre-class watching performance increases, and the confidence also increases. And that also shows up on the final exam. And so I've been able to show some good correlation between how the students do on the pre-class videos and their final exam performance. So that's coming in from all the data that I get from the videos and the quizzes that are embedded in the video questions. So that's basically my take on this. I do the flipped classroom in the studio style or the large lecture halls. And in both cases, I have seen the same outcomes from the students.
Amaya, one of the things when I talked about it in the past, and I thought was really interesting, your original videos were longer in time, right? They were 20, sometimes 30-minute videos. Talk about the analytics that you were able to look at through.
Sure. So initially we had, so I made these long videos because they were supposed to be lecture replacements. And so since the lecture is 50 minutes or 75 minutes, my videos were also 20, 30 minutes. And so longish videos. And so we first posted it on YouTube, and the YouTube analytics told us that students' viewership just drops precipitously in the first even a few minutes. And so that told us that this is not an effective way of doing the videos. So we shortened the time of the videos, like 5 to 7 minutes, which what literature also says is a good time for videos. And then we put in these interactives in the videos, the questions and all, so that the students don't just fall asleep or turn the video on and go elsewhere and come back. And so that has now resulted in about 90% of the students watching the videos to the very end. And a lot of videos also are watched over and over again. So we see a lot more viewership than the actual number of students in class. So there's a lot of engagement also.
I just have one more question for you, with something that, again, we've talked about, and I think is a really interesting takeaway that you got from this. When you see a video and you can see through the analytics that there are 30 students in a class and the video has been watched 90 times, it's an indication to you that the videos are watched over and over again. And that could be one of two things. It could either just be a challenging topic and therefore the students need to spend more time with it, or it could be that the video is confusing in some way. How do you tell the difference between those? What information and data do you gather? And then how do you respond to that?
So it's a good question. So the first thing I do is talk to my students directly, and they tell me directly what's going on. And I also use learning assistants in class. So the learning assistants also tell me directly what was the matter with the video. Was it the video or was it the content? And in certain cases, it's quite straightforward. If I put people in there, then it gets watched over and over again, even if it's a simple topic. And if it's a difficult topic, like any rotational motion thing, then the topic itself is difficult. And so I expect that the students will watch it over and over again. So the quizzes that are embedded in the video assignment, they are a good indicator of whether it's the concept or whether it's the video. And even their self-assessment or the reflection of how much they understand themselves. So the question that I asked later, how confident are you in this concept? That is a clear indication also of whether they find the video useful and the concept too difficult, or if it's the video that was confusing itself.
That's great. Thank you so much. Yeah. That's very helpful. I'd like to open it up to Dr. Chris Dustin now to talk a little bit about this. I could just introduce Chris a little bit. He got his PhD out of Florida State, where he was integral to the studio-based offering that Florida State has, and really got him on a path of the flipped classroom. And since he has been at Merrimack College, has been doing the flipped classroom fully and recording his own videos. He has refined and changed his videos a lot, as much as anything, with the form in which those videos are offered. And Chris, so can you just talk a little bit about the same things that Amaya just discussed related to the whole process of you producing videos and refining those and getting feedback and collecting data?
Yeah, sure. Thanks, Jeremy. I hope everyone can hear me. Yeah, so I was hired at Merrimack. They wanted to transition to a studio environment with the possibility of flipping if we found a way to make it work that we liked. That was 4 years ago. So they hired me and we started experimenting with putting some parts of the lecture outside of the class on video. And at the beginning, a lot of the innovation was what kind of technology can we use to do this? So we started by filming ourselves at a blackboard or at a whiteboard. We found that to be rather awkward, turning to the camera. Where were you supposed to look when you're doing that kind of thing? We switched to using tablets and handwriting. We did do some voiceover PowerPoint presentation stuff. And now we've transitioned to doing some lightboard stuff as well. So if you know those fancy YouTube videos where it looks like people are writing in space, we have one of those. It's called a lightboard. I'll just point out that one of the things that we found our students enjoyed, which I may have mentioned, is either seeing somebody on the screen or not seeing somebody on the screen. So a lot of our innovation was based on whether you could see the person and whether you were just looking at handwriting. So we played around with like that kind of technology, and actually one of the things that the Expert TA video library has done is it's transitioned away from our handwriting on tablets, which, I mean, right, I'm a physicist, my handwriting is relatively terrible. My students get used to it, right? But if you want to produce a nice video, one of the things you have to do is you got to convert all of that handwriting, you know, although nice presentation, into this clear, well-formatted, nice diagram sort of format. And so it's been really nice to see that happen on the Expert TA video library. So we had that sort of technology part that was happening, but also we had the content part. I mean, we did what EMEA did. We just said, well, we're going to replace lectures, so let's just speak like we're presenting a lecture and then put it on YouTube and see what the students do. And the students essentially didn't watch them. Even though they were shorter than a 45-minute lecture, they were not that interested in sitting there for 20 or 30 minutes watching us speak. So we basically did a sort of guess and check sort of thing. We'd take a video where we know the percentage of watching was low, and we'd try various things like break it into shorter chunks, make it more modular so that the students wouldn't necessarily have to watch immediately after one another. They could watch one and then a little bit while later when they had time watch another. We did find that students had a much higher probability of watching those types of chunked modular videos in the sort of like 5 to 10 minute range is what we found to be kind of optimal. And you could see it on the YouTube analytics that those videos were just watched more than the long lecture videos. The other thing I'll say about that is that the effect that Amaya was talking about with videos having more watching than students in a class, we saw that predominantly with example videos, which I think is not that surprising. You know, students like a nice clear lecture, but they also really, really like examples. And my students, you know, if they did an example in class they didn't get, if I put an example video where I describe the solution on YouTube, they would just watch that over and over because they knew that that was going to be on the exam. They like to see me solve problems. A lot of that is how I teach class, which is I don't do a lot of problem solving. My students do a lot of problem solving, but I mean, we definitely saw that effect. So the other thing we saw which helped engage students is basically making the videos have some credit associated with them. So in the beginning, it was very successful to tell the students that, you know, before class, if 90% of you watch the video, I'll give you a point for the day or something. So that was actually very useful in getting the students to watch every video. I could see from YouTube that they were watching them. But of course, that doesn't really guarantee that they're learning anything or really watching the video with any intention. So then we sort of transitioned to the shorter video format along with a reading quiz sort of assignment. Or a video watching quiz kind of assignment at the beginning of class, and just advertise to them that if you watch the videos, you will take this quiz and you will do better on this quiz. And that's what Amaya did, I know, by integrating the quizzes into the videos. And that's what we've done at Expert TA too, is we acknowledge that the students will engage more if they believe their grade is directly dependent on it. And so by putting quizzes right into the video, they see the quiz, they know if I watch this video, I will get points on this quiz. That will say to the instructor, I watched this quiz, I watched this video and took this quiz. And I think that just sort of makes the whole thing make more consistent educational sense. And that was our experience at Merrimack before starting with this Expert TA project. And it's been nice to see that that part is being built in as well, because I think it's a really critical part of it. I don't know, is that about what you wanted to hear?
Oh, that's great. Yeah, I think that provides a lot of really good information. We have about 10 minutes left, and there are some questions that have been coming in from audience members that we would like to address at this point. So one of the first questions is, can students watch or access videos if they aren't assigned or if the assignment is closed? And the answer to that is yes. For ones that are assigned, there is a window of availability, and the students need to do those quiz questions that are associated with the videos. But as I mentioned earlier, there will be a link in the additional class resources that both students and the instructor can access at any time, which takes you to this landing page here. So if students wanted to watch all of these videos in the first 2 weeks of the semester, or at the end of the semester, if they wanted to go back and, as they were reviewing for the exam, watch some of the earlier material, they can access these links during the entirety of the availability of the course between the start and the end date. There was another question about whether we plan to continue to add more videos in coming years. Yes, we have 65 Physics 1 videos. We will go to 90 or 100 Physics 1 videos based on covering more material. We don't have, for example, in this list right now, thermodynamics and superposition and some other topics here that will be added. And then we will probably add another 50 to 70 Physics 1 videos just adding examples. And some of these examples will be the expert TA problems that are fully walking them through an expert TA problem. So we're thinking about how to place those. We may not put those in an area where students can access all the time, mainly because it would eliminate instructors from being able to use that question if they really like it. You don't want to solve that for them. So we may have a different way that the instructor can give those example problems to students. And then the final comment is that Physics 2 for fall 2019, you're going to expect something very similar. Complete comprehensive coverage for E&M, optics, circuits, and all the way up through the modern physics content. You're going to see that. Lots of example questions. So we'll be adding lots of videos in the coming years. There was a question about whether or not the videos are aligned with a specific book. As you can see from the breakdown here, we have arranged these by topics, and we've tried not to have it structured in such a way for this presentation that it's associated with a book. It's got 1D motion, which will show up in any introductory physics textbook, but that won't necessarily be chapter 2 or chapter 3. It will vary. So we've tried to make this to where it can be used with any book that is available. Being handed another question here. The question is, what formats are current people using videos? The current users of Expert TA, including, I could say, one large adopter, all of the university physics at Texas Tech across all of their sections are using, and they are migrating towards a flipped classroom. It's something that they have wanted to do for some time. They're not on a full flipped classroom right now. They still have a lecture section, but they have recitations where the TAs hold problem sessions and show additional in-depth work. And so they are now using the videos for that rather than having each TA try to present the theory or work those materials. They are using the videos for that. And then the TAs and the students work more complicated materials together. And I guess we could go back to Chris and Amaya for this in just a moment, but we might just state a case for why you might go to the flipped classroom or start heading in that direction if you haven't already. I know that many of you teach the same classes semester after semester. Sometimes you have multiple sections of the same Physics 1 class in one semester. Is it really the best use of your time to go and to repeat yourself deriving the basic kinematic equation? Why not get that on tape one time so that you can put that to your students? Some of the benefits that maybe are not thought about, imagine a current lecture. And I'm going to talk about a larger lecture section just so I can include one component here. There's 300 students in a class, and there's a student sitting out there who doesn't understand what's going on and would really like to ask a question, but they may not because of being intimidated by raising their hand in a class that big. The question of, am I the only one? Is it going to make me look stupid? And so sometimes students don't ask questions because of factors like that. And there's other times where maybe they're not shy or intimidated, but they just don't think about it. So the material is being presented, they can't quite formulate what it is they need to ask, and they've missed their opportunity and they leave the class and say, I really wish I had asked this. With videos, especially if you're supposed to watch ahead of time, you can pause, you can rewind. You don't have to scramble to take notes as fast when you can pause. And when you come across a question, you can email your instructor. Not everyone has to know that that question came from you. You are more likely to get student engagement in a format like this because of some of those factors. Now, the students come in and you don't have to spend 15 minutes deriving the kinematic equations. What does that mean? That means that you could work more example problems maybe than you would, or talk more about the application, do more complicated things in the lecture. And so those are some of the benefits. My final comment about how we're delivering these videos. Right now, it's an all or nothing. Do you want to do the full video collection or not? We will be releasing a subscription model soon for folks who really don't care about the flipped classroom at all. Imagine having access to just the worked examples. You could see having a lecture, presenting the material like you always have, and you only have time to do one example with your students in class. But what if you had access to several videos of worked problems that you could put out there for them, but you wouldn't necessarily want to have your students pay $32.50 for that. So in the future, there will be a model of Expert TA that if you decide, I'd really like to have a subscription that allows me to use, there's 14 weeks in a semester, I'd like to have something that allows me to get to 28 videos, 2 a week, the 2 example questions, then you could get to that, and the price for the student may be something more like $10 to adopt that. So the homework system for $32.50, and then $42.50 to get the extra supplemental worked examples. So there are other options for how these are being delivered related to the format of how people will be using them in the future also, and I thought that related.
And we have one final question here, and it says, in the calculus-based course, an area of difficulty is application of calculus in the various topics. Do you have videos that address this issue?
We are putting together videos that address this issue. So you can see up here at the very top, the units and physical quantities. We have algebra review, dimensional analysis. There are other non-physics videos that are coming related to exactly what was just asked here. Calculus review, linear algebra, matrix theory review. We'll plan to add videos in those areas as well. That's all part of the expansion that was asked about earlier. I see we're at the top of the hour. I really, again, appreciate everyone's interest and taking the time to talk with us today. Dr. Dustin, Dr. Kolakar, do you have anything to add before we hop off?
I can quickly talk about the videos being useful for accessibility. So I've had some veterans stop by saying that they've just come back from wherever the deployment was, and so some of them are suffering through PTSD and they cannot read that well, but the videos work really well for them. So that's a powerful statement coming from them too.
Yeah, I definitely agree with what Amaya just said. I'll just also add, I think the flexibility of having these short videos opens up a lot of possibility for instructors who want to do very specific things. Like, you know, for one particular class, you want more time in class to do something. Moving some of the content out to videos allows you to do that. So I like the idea of the flexibility that that this brings into the classroom. At least I hope that's what we've managed to accomplish, is allow other instructors to have the kind of flexibility that I feel like I have when I have my own videos.
Okay, that's great. Well, again, everyone, thanks for your time today. We hope that this has been informative and that you feel that this has been worth the hour that you spent with us. I hope everyone has a great day. If any of you have more questions that were not answered during the presentation today, feel free to reach out to us. We'll be happy to answer them. Thanks so much.